Hello guys, welcome back. In this video, let us learn more about Redshift. So for this, let's take into consideration of DynamoDB. How data is stored in DynamoDB? In DynamoDB, data is stored based on your partitioning key and sort key. So based on in DynamoDB, your data is stored based on partition key and sort key, right? Yeah. So why DynamoDB stores in that format? To provide a quick query performance, query response, DynamoDB stored in that way. So here also in Redshift also, your data is stored by using sort key. How your data is stored? By using sort key. So why your data is stored by using sort key is to improve performance, and to provide query response faster. So let me frame the whole thing in a single sentence. To improve query performance. To improve query performance, your data is stored. Your data stored by using sort key. Yeah, I hope all the points covered. So by using sort key, your data is stored in Redshift. So for what? For to improving the query performance. To provide fast query response and provide the fast performance. Your data is stored in the form of by using sort key. Okay. By using sort key, your data is arranged in a sorted order. Okay. Now let's say I'm having some data. I'm having some data. In my table, I'm having some data. I deleted that data. What happens? Just there will be some space created. In between, whatever the disk we have, some space is created in between the disk. Wherever we deleted the data, there the space is created in between disk. Now, is it good to remove? Is it good to leave that space without using? No, right? We need to claim that space, claim that disk space after deletion, right? Yeah. So in order to reclaim disk space after data deletion, we use what we use? Vacuum command. What command? Vacuum command. For what we use vacuum command? To reclaim disk space. To reclaim disk space after data deletion. To reclaim disk space after data deletion in Redshift. What we use? We use vacuum command. Which command we use? We use vacuum command. So this command is used for what? For reclaiming that disk space. Okay. This vacuum command also used to keep your data in sorted order. This vacuum command is also used for what? This vacuum command is also used for to keep your data in sorted order, to keep data in sorted order. Okay. Vacuum process helps to redistribute data across shards and reclaim the space. How this reclaim the space is, how this vacuum command reclaim the space is, it again redistributes what are the shards we have, what are the data we have, what are the data we have, that will be redistributed, and it by using that it reclaims what are the empty space we have. So vacuum process helps to redistribute data across shards and reclaims space. What are the space present that will be reclaimed. So by using this vacuum command, whatever the space which is created due to data deletion will be reclaimed by using this vacuum command, and by using this vacuum command your data is again redistributed and kept in which order? Sorted order. Okay. One more thing, since this vacuum command is performing these many tasks, this vacuum command is costly, expensive. Or this vacuum command is expensive also. You need to remember this point as well. So when do we use vacuum command? We use it for reclaiming whatever the space that is created due to deleted data on my table. And even after reclaiming the space, what it will do is how it reclaims space is by redistributing whole data again. So in that way, it will reclaim the what are the space that it has, that will be reclaimed. Even your data is redistributed in sorted order. Again, this vacuum command is expensive. Okay. So let's say at the first time, I hope you watched the previous video all about a copy command. Now let's have question on that copy command. Let's see the updated version, or else if I use copy command, what happens? If I use copy command, what happens? If we use copy command, then whatever the data you have, the data is just appended to end of the table. Your data is just appended to end of the table. That means whatever the previous data which is present on the table, that again remains be in the same place only, right? Yeah. So by using copy command, what this copy command will do is whatever the table data you have, that will be just appended at the end of the current table. Let's say I have this table in my Redshift, where this table contains ID and name, and it is having two rows of values. That is one value is Sai and second ID value name is Ajay. Now what I'm expecting is I want to use copy command to copy this data from S3. So I used the copy command. I provided this as my destination bucket and I provided this as my source bucket. So from this, the data is copied to this table. So here you can see the total combination of resultant table will look like this. So can you observe here 2 times 2 came, right? Yes. That means in ID, I am getting duplicates also, right? Yes. So if you assume this ID as sort key. So how your data is stored? By using sort key, right? Yes. So since you are having, let's say this ID be the sort key. Now, is it possible to get duplicates when we use copy command? Yes. There will be a possibility to get duplicates when we use copy command, right? Yeah. So if I use copy command to copy data from source table to some destination table, where my destination table contains some data, then what this copy command does is it just appends the destination, the source table data to the destination table data. Here you can see what this copy command do. It just appends at the end. So if I use the copy command, then what happens? There is a high probability of my data duplication, which is possible in Redshift, right? Yeah. Is there any built-in command? Is there any built-in logic available in copy command to check for the existing rows, existing records? No. So there is no built-in logic to check for existing records. So that's why this copy command will having a high probability of data duplication in Redshift. Now I want to perform some command. I want to perform some operation on my destination table or else and source table, so that to get the resultant table where it does not contain duplicate data. It does not contain duplicate data. That is, I want to avoid. That means whatever the data like this we have, I want the data like this. Here you can see the duplicated data is gone. That means we are updating whatever the duplicate data we are having with what? With the source, with the source data. Since I want to copy the source data to the destination, now since I'm having the same key twice, here you can see 2 came here as well as here. So in order to avoid this duplication, what I want is I want to provide, I want to update, I want to delete this, I want to remove this, and at this position I want to insert this Ajay1. In place of Ajay, I want to insert Ajay1 because this is the data that I am copying, right? Yeah. In this way, I want to avoid this scenario, this case. To avoid this, we use UPSERT. What UPSERT? What is UPSERT? Obviously, everyone will confuse that I spelled a wrong word, but it's the correct word only. You can use UPSERT. So by using this UPSERTing, you can able to do updating. In place of Ajay, you can able to update Ajay1, and even you can able to insert what are the new records are there. Here you can see what is the new record, that is Spark 3. That is a Spark that will be placed, as well as here you can see in place of Ajay what is replaced, Ajay1. That is nothing but updation. So these two things, both updating as well as inserting, will combinedly done by using UPSERT. UP stands for updating and SERT stands for insertion. So when do we use this UPSERT? To avoid data duplication for sort keys. Here you can consider ID as sort key. To avoid data duplication for this, we use UPSERT instead of copy command. So what does this UPSERT will do? It will update as well as insert new record. By using this UPSERT, both updating the value, that is in place of Ajay, we are updating the value of Ajay1 because we are copying the source table, and we even inserting the new record, that is what 3 Spark, that is also we are inserting. So these two things will be done by using upsert. UP stands for what? Update. Third stands for what? Insert. So since these both are done by using upsert, we can go for upsert instead of copy command. So in order to avoid this duplication and do these two tasks, we go for upsert instead of copy commands for the not for the next times. That is, for the first time we use the copy command. Since no data is there, what are the data we put, that will be stored. Okay, but if we want to store during a second, third or fourth like that times, then we need to use this upsert. So is this upsert command available in Redshift? The answer for this is no. In other databases, we have upsert command, whereas in AWS Redshift, we do not have this upsert command. Then how can we able to implement? Then how can we able to implement this upsert? Then how can we able to implement this upsert? We can able to implement this upsert by writing separately queries, by writing separate queries. So in order to implement any query like updating or else inserting, we must require the two data must be present in my Redshift database. So in order to get this to Redshift database, first what we create the schema. Every table has its own schema. The schema is nothing but it's a what are the columns it has, that is id and name, and what are the data it contains, that a type. Id contain integer type and name contain string type data. So specifying those details is nothing but schema for a table specifying those details. This table contains id of integer type and name of string type. Specifying the description for a table is nothing but schema. So first we need to create schema. We need to create a schema with, we need to hold a temporary table. We need to hold a temporary table. So let's call the table as staging table. Since it's a temporary table, we call it as staging table, or whatever you want, like that you can call it. So step 1 that we need to perform under this upsert process is create staging table with the same schema of destination table. What are the destination table we have? For the same schema, by using the same schema, you need to create a staging table. So if you create a staging table, then the schema will be like this. That is, it is also having id, where this id holds integers, because in your destination table it holds integers, right? So this id also holds integers. And name, right? Staging destination table also contain name. So staging table also create name, where this name holds which type of data? String data. So that will be described, in this first step. So first this will be created. Then next step, the next step is we need to copy whatever the data which is present in the source table, that we need to load, or else we need to copy the data into staging table. Now in the second step, what we are doing in this upsert process is we are copying or loading whatever the source table data, that data to where, what are the staging table that we created under our Redshift. So if we move, or else if we load or copy our source table data to staging table data, then our staging table data will become like this. So for this particular example, it become like this. Since under source to source table we contain this data, so the data will be copied to where, our staging table in the second step. In the third step, what we do is we need to update our destination table or target table which is present in your Redshift. So we need to update the value of your destination table based on what? ID. Based on ID. So if any ID is matched with the uh, where your data is present, where your source data is present in your Redshift in staging table. So first you need to check your IDs of your destination table and staging table, and if there will be any match found, for your IDs, this ID is nothing but a unique ID actually. So if there will be a unique ID match will be found, then what you do? You need to update this, right? You need to update this value with whatever the new value of staging table, right? Yeah. So that you need to perform in the third step during this upsert process. So after this, that is after updating or joining our destination table with based on unique ID, what are the ID that we taken, based on that, if we join our destination table by using the staging table, the source table is stored in where? Under staging table we store the source table. Now these two present in Redshift, so we can able to perform insert or update operation between these two tables under Redshift as well. Now you can see based on the staging table and destination table, based on the unique ID, we taken here ID as the unique ID. So based on that, what we did, we did just updating. So after the updating, what updating we are doing? We are doing the destination updating or destination or target table updating. So after checking the unique IDs, we got two as common in between them. So in place of Ajay, what value is updated? Ajay one is updated. Now you can see here under the destination table will look like this. After the updation, your data will look like this. Now at last, in the fourth step, what happens is now we insert new record data to the destination table. So whatever the new record data which is still present in staging table, but the data is not present in the destination table. So based on the unique key, it will identify the new record. So here you can see 2. 2 is already present. So no insertion happens. 3, you can see 3 is not there, right? Yes. So that row will be inserted again here. That is the fourth step. Here you can see now insertion of new row of staging table to destination table will happen in the fourth step. At last, now you can see we get the destination table with both updating as well as inserting. That is nothing but we done copying and remove the duplicates. Here you can compare. We got our table like this, right? Yeah. So we performed this upsertion, but at last, we even having this staging table, right? So deleting that staging table is also important, because if you delete that only, then you can able to get some extra space for this staging table. So that is the last step. So in this way, by using upsertion, by using upsert process, so these are the steps that you need to follow for performing this upsert process. In this way, you can able to eliminate the duplicates while we perform copy command. This upsert process even updates the existing table and even insert the new records, right? Yeah. So in this way, we can able to eliminate duplicates and we can able to insert new records in the table, in the destination table. Since we are not having upsert command directly, what we do under Redshift is we can perform all these steps. We can perform all these 5 steps by using commands by using SQL commands. Here this Redshift uses Postgres variant, so that's why we prefer to use that Postgres variant commands, and just we need to return those whole commands in a single file, and we just comment it once, so that all these things will be happen. So that all these things will be happen. All these upsert command things will be happen. So this is about upsertion of your table. Now let's see how to write the commands to perform these tasks in Redshift. Now let's see the sample commands for that. Now in the step 1, what I want to do, I want to create a staging table with the same schema of my destination table, right? Yeah. So let's write command for it. This is the command to create a temporary table with name staging table. Staging underscore table is my temporary table name that I am creating with same schema, same like what are my target table. My target table here is target. In the target, my target table is present. So if you want to create a temporary table, this same like write this command, create temporary table, whatever the table uh, you want to create, that name you need to provide here. Since I'm expecting to create staging table, I provided staging table. Like whatever the schema you want, that table name you need to provide here. Since I'm expecting target table, so write target here. Now in the second step, what you want to do? In the second step, you want to copy or load the source table data to staging table. This source table data you want to copy or load to where your staging table, what are the created staging table. For that, you have already seen the commands by using copy command, how do you can able to copy. So that you already seen. You can see this is the general syntax for it. So those who unfamiliar with this syntax, then please watch the previous video about how to copy, how to use the copy command, so that they can get some idea about it. Now let us write that command here for the step 2. So write copy to staging table, and from where that also you need to provide. I'm taking from S3 bucket, the bucket name is my bucket, and within that bucket I have my file name is file1.csv. In this format my file is there. Then in final you need to provide IAM role. So IAM role you can provide by using ARN. ARN represents Amazon resource name. AWS IAM, it will be like this: 0987654321 like this the name will be. And after that role, then it will be like role 1 or whatever the role name that you provided, like this it will be. And at last we have semicolon. So this is the command where you can able to copy the data from where, from S3 bucket file1.csv to where, staging table, which is present in where, inside your Redshift cluster. So inside your Redshift cluster, you can able to create this. You have already created this table, and now you're copying the data from S3 source to this staging table. So this is the, for doing this, you need to use the command this. Now, what is the third step? In third step, you need to update the destination table based on unique ID. So for this, let's write command. Here you can see we are taking target as T and staging table as smallest, where T dot ID, that is nothing but in the target, whatever the ID is there, that will be equals to S dot ID. What is S? Staging table dot ID. That means here we are comparing the target ID with staging table ID. Whenever they are equal, then what we are doing? We are setting the name. We are setting the name as S dot name. Here, what name we need to set? We need to set our source saved name, source table name. That is nothing but our staging table name. What is our staging table here? S. So S dot name will update the name of your target bucket as whatever the name in the staging bucket. So here you can see it will be valid only when ID is 2, because when ID is 2, what happens? This condition will be valid. That is T dot ID. T means what? Target. So target is nothing but our destination table. So that target dot ID is what? 2. Whereas coming to S dot ID, what is S dot ID? That is also 2. There you can see they both are matched. What is S? S is a staging table. In that ID, we have 2 is matched with the destination table ID 2. So there Ajay will be replaced. So since previously we were having Ajay, due to this command, we set the name as what? S dot name. What is S? Staging table dot name. This is my staging table, and under this, the name for that particular ID is what? Ajay1. So that will be set to where name of our destination table. So by using this command, this will be executed. So we just updated or updated the destination table based on unique ID. Now, fourth step. What is that? Now insert new row of staging table to destination table. So what we are expecting to do? We are expecting to insert whatever the staging table new rows present to our destination table by using some command. So let's see how the command for that as well. Here, this first line, that is insert into target. This line specifies that you want to insert data into target table, which table? Target table. This second line, that is select S dot star. This line represents select all columns. Star represents select all columns from where? From S, where this S is aliased in the third step. How we are aliasing? We are aliasing from staging table. So from the staging table, we are selecting all the columns here in the second line, where we are aliasing. Where we are aliasing? We are aliasing in the third line. We are aliasing in the third line. Yeah, we are aliasing in the third line. Staging table is aliased as S. That is nothing but we can able to call this staging table with short name, that is S. We can able to use the data which is present in the staging table by using the short name S. Okay. So what about the next line? That is left join. Left join target T on SID is equals to T dot ID. So what about this line indicates? This line specifies this line performs a left join between your staging table and the target table. Based on what? ID. Based on ID, it will perform left join. This join will include all the rows from your staging table and matching those rows from the target table. So here T represents Here T represents its aliased from target. Since we written like this, T represents aliased from target, same like S. In the last line, you can see where T dot ID, where T dot ID is null. This condition filter out the results to only include rows where there is no matching ID in target table. We are only including the rows where ID is not matched in the target table. So whatever the staging table IDs we are taking, those IDs not match with the target table ID. Those only we are taking here, where T is null. T dot ID is null. What is the T? T is a target table, right? So for that ID, the target table is not present. That ID is not present in the target table. Those only we are taking. So this effectively filters out the duplicate records and only insert new records into my target table. So overall, this query inserts rows from where? From my staging table. From my staging table into the target table. Into the target table. But if there is no matching in the ID in the target table to avoid duplicates. So this is what happened at the back end. So what is the last step? That is deleting the staging table. So it will be automatically deleted after executing all these commands once. So after since the table we created is a temporary table, so it will be deleted immediately after executing all these queries. So now let's write the whole into a single file. If we write the whole thing into a single file, then it will look like this. So you can see I have written whatever the commands that I have told, those only I written in between my begin and end. So you can see in between my begin and end, I have written whatever the commands that we discussed in the 5 stages, those are written here. So now what I do is, in order to perform this whole thing, this upsert process, I just once run this, once commit this, then what happens is my upsert process will work. That's it. So in this way, you can able to perform your upsert process on your Redshift by using this whole code. So here you can see I just written a begin and end. So in between that, I have written what are the code that I have explained now. So all the individual queries I have written combinedly and just provided here. So once write this, save it in a file or else save it, then you can just commit it only once. Then all these 5 steps will be done. That is nothing but all your upsert process will be done, and you got the required copy of your table from your source to destination, even eliminating the duplicates. So at the time of telling about sorting and vacuuming, I also mentioned that they are expensive operations, right? Yeah. So use this upsert to copy new data into a table. The table need to be sorted, right? Yeah. Since upsert performs a delete, it may leave the table in unsorted state as well. When a record is deleted from the Redshift table, it only marked for deleting. It is not automatically removed. So we use upsert to copy new data into a table. The table need to be sorted. Since upsert performs a delete and leave the table in an unsorted order, when a record is deleted from Redshift table, it is only marked for deletion. It is not automatically removed. So this is all about when do you use the upsert and about a vacuum command, sort key. So I hope you understood this video. If you feel this video is contentful, then please like, share, subscribe, and hit the bell icon to get the latest updates. So don't forget to comment so that it will reach to many audience. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys. Thanks for watching again.